2. All right, I think we're live. All right, everyone, welcome to another daily dose of LeetCode. Here with me, Rafael Negron. Today we're going to be continuing from where we left off yesterday in our journey to do every single question on LeetCode. Just as a quick housekeeping, so if this is your first time here, first time watching the stream, the best place to start is on the LeetCode Live playlist. You can start from this first one here and then just keep watching them. You can try to catch up to where we are today, but you can just keep going along every single stream, and it makes it very easy for you to sort of catch up to where I am today, and it's a nice way to guide yourself to be able to get over 100 questions like where we are today. Each one of these different videos has chapters to all the different questions that we solved during the stream, so it makes for easy navigation, and you also get links to the individual questions on LeetCode, which is pretty cool. If you want to get notified anytime I go live, just go ahead and subscribe to the channel. Also ring that notification bell. It'll make it a lot easier for you to see all my live streams as they come up, and that way we can all, keep it up together and sort of like hit our marks together. I think that'd be really neat. So let me just open up the stream view so I can get, okay, sweet. All right, cool. So we're gonna just go ahead and start from where we left off yesterday. Let me go up to the question here. I think we left off on this one, but there was, and I think we felt like maybe we can do this one in a greedy solution, but probably we'll have to revisit this one at a different moment, weekly roundup, or maybe at some other time. So let's check this one out. Okay, starting off with a nice high quality question, which I love. So a distinct string is a string that is present only once in an array. Given an array of strings R and an integer K, return the kth distinct string present in R. If there are fewer than k distinct strings, return an empty strings. Note that the strings are considered in the order in which they appear in the array. Okay, how long is this? Array.length is 5,000. An array, okay, so each word, all right, and RI. So I wonder if because there's DB, let me see here. Imagine we have, one of the first things I think of, I don't know if this is really counting sort, but I almost think of keeping track of the frequency of these different words in something like in an array. So let's say we have, like what distinct letters do we have in here? D, B, C, B, C, A. Right, but D appears how many times? Like D appears once, B appears twice, C appears twice, and A appears once. It's a first distinct string, so it's a second distinct string. Yes, what I think we could do is really we can just go, is there any reason that I can't use a hash map for this? I can get the frequencies of all of them. And then let's say the first time I find one, I'll just have to make sure that's the kth one that I'm looking for. That's one way that I can do it. Or I can also just make an array of size 1000 like we have here. 1 is less than k is less than or equal to r.length is less than or equal to 1000. That is something that we could do. But thinking about it now, that's not going to be right. It's not so much of like, well, could we? Yeah. How would we? If I wanted to enter this in some index in an array of length 1000, I might have to sort of figure out a key for this. Here, you might be tempted to think that, maybe D would go in some normalized index. When I say normalized, I mean we would find the index of D by doing, the thing that we do with A minus 97, and then essentially it'll be D minus 97. But in this case, I think keeping a hash map will be better. Hey, Rashawn, how you doing? Really good to see you around. Thanks for joining. I'm doing pretty well. It's been a pretty great day. Nice weather here in Florida, and just enjoying it. So looking forward to getting on with the stream. So let's do this. Let's create an object literal here. Let's say frequency. And now for const, this is just going to be words. I can just say C or something. It doesn't really matter. Or for const word of R, here I can keep track of the frequency. So frequency of word equals frequency of word plus 1 or 1. And just to sort of make this a little bit easier to read, I'll put this on a new line. And now what we can do from here is we can loop through R again. And then anytime we find one, let's say we find a unique one, but like it's not, well, I guess we can say we subtract one and then we subtract another one. Whenever this is 0, it's when we return the answer. So I can sort of say for const word of R, if frequency of word is equal to 1, then we can say k minus equals 1. If k is equal to 0, then we can say return word. And I think, is it guaranteed? So if there are fewer than k distinct strings, return an empty string. So at the end here, we should just be able to return an empty string. How's your day been, Rashawn? Let's see this one here. Return, oh, does it not want me to return? It doesn't like that I do it like this. Let's see this one here. Oh, literally spelled it wrong. Yeah, that was confusing. I wasn't sure why I was complaining. So that's A and A. I'm just running it too fast. Just give me a second here. A, empty string, okay. 92.25. So yeah, we're off to a really nice start here. I'm in South Florida, but yeah, I know of West Palm. I've driven by there a couple times. Never really enjoyed any time there. I think it'd be cool to be able to spend some time there. But yeah, it's fun. I grew up here in Florida, so I really do love it. I honestly love the weather. I love the heat, so it works out pretty well for me. Okay, sweet. So what is it that we did here? Let's do like a quick analysis of this question. So let's first think about time complexity, right? So this is just like a statement, just like a single expression. This is just constant time. This one, we're going to have to go through every word in array. So this will be an O of n. This will also be O of n. Now, do we necessarily have, I guess in the worst case, the distinct one could be at the end. So we'll go all the way to the end. So this will be an O of n time complexity algorithm. As far as space goes, our frequency map will have to hold every single word in array. So it's going to trend to the size of whatever array is. So it's also going to be O of n. So we'll have a time and space complexity that's linear. Very common pattern, something that you should be very comfortable doing in your interviews, just being able to, create an object literally like this and keep some frequency or some other information about your inputs. So yeah, I like this question. I'm going to actually like this question here. I'm going to add it to my list. This list that I'm compiling here, you can always find a link to my lists on the YouTube description for the stream. So if you ever want to go to it, just look in the description. You'll find it there. All right, so that was kth distinct string. Okay, make two arrays equal by reversing subarrays. Okay, you are given two integer arrays of equal length, target and array. In one step, you can select any non-empty subarray of R and reverse it. You are allowed to make any number of steps. Return true if you can make R equal to target or false otherwise. So we're given two integer arrays of equal length. Okay, so 1, 2, 3, 4 and 2, 4, 1, 3. You can select any non-empty subarray of R and reverse it. Ooh, this one's gonna be tough. You can follow the next steps to convert R to target. Reverse subarray 2, 4, 1. Oh, wait a second though. You can always make one string. Yeah, okay. I think I know what we need to do here. So this question, and I almost sort of fell into that trap until I sort of understood it a little more. This question is very easy to think that you might actually have to sort of like permute or figure out some sort of like all the permutations of this to see if it will ever equal this. But I think what we can do here, and at least the thing I'm going to try, is if we're given, we can always place these digits in this order such that this array will equal this array. And I'm pretty sure that, we can keep reversing subarrays to eventually get there. I mean, we could do that, right? This one's true. Okay, true. 379, like this already sort of is a deal breaker for us here. Like 3, 7, 11 is not included. Like 11 is not included in the first one, so it can never be converted, right? So I think what we can do is we sort of store all the numbers that are in the first one, and then for the second one, if all of these are included in here, then that's good. And I wonder if there's like an easier way of doing that. Right, because 379, let's say we like put this in a set, and then we just go through this and loop through the set. So I think what we can do, let me see, 379. I can also put them in on, yeah, is a set, I think a set becomes an unordered set, but really I can just say, no, I think a set will be better. So let's create like const target set equals new set of target. And then here, can I just return r.every, let's say value dot has, or I'm sorry, value target set dot has value. Let me just check my, okay, that was the mailman that came through. Right, so we created a target set of target, and then if every value in R is contained in my target set, then we can do that. So I'm just going to go ahead and run for all the test cases here, and let's see what this gives us. So true, true, false, true, true, false. Now, is creating an unordered set, if it's just going to be a hash table, as far as I know, that's usually what it is, right? What's the time complexity? Like here, I'm having to loop through everything in target, so this will be O of n. Well, let's first submit this and then think about this, right? So 1, 2, 2, 3, 1, 1, 2, 3. Okay, so it's not enough to say, oh, okay. So it's not, because the set's only keeping track of distinct numbers, so it has to be exact frequencies. So because of this, I think, so yeah, instead of this, let's say target frequencies. Target frequency is an object literal. And then what is it that we can do, right? We can start building up our target frequency. So for const value of target, again, just like what we did in the previous one, target frequency of value equals target frequency of value plus 1 or 1. This will give us our object literal that has the frequencies. Now let's think about this next piece, right? We have 1, 2, 2, 3 and 1, 1, 2, 3. There's like two different things that can happen here. In the first one, we have 1, 1, we have 2 2s, and we have 1 3. The next one has 2 1s, 1 2, and 3 3. So there's sort of like, or 1 3. There's sort of two cases here, right? A number from, so we can say a value from R does not exist in target. Here we can just return false, or we can say that target frequency of value minus minus is less than 0. Right? Because anytime we use a value, it should never be lower than 0 if there's an equal amount. So I think we can sort of have for const value of target, we build up this target frequency, and now we go through our array. So for const value of array, we can say, we can have two test cases here. So if we say if target frequency of value is equal to undefined, that means this one has a digit that's not in target. Here we can return false, right? And now I can say if target frequency, let's see, what do I want to do? I want to set it equal to, I want to use it first. So I subtract it, and then I check it. So if minus minus target frequency of value is less than 0, we can also return false. And then at the end, we can just return true. So let's think about this, right? Let's sort of like go through this example again. We have 1 2 1. So we say for const value of r, which they gave us over here for r is 1, 1, 2, 3. Let's start going through it. We say 1. Is target frequency of 1 undefined? No, it's not. Now we can go to negative, negative target frequency value. So we do this. Is it less than or equal to 0? No, it's not. Now we go to the next one. That's another 1. All right, now we go over here, and this is already negative 1. So that's we know it's not going to be true, right? It's going to be false just in that moment right there. So let's give this one a shot. Let's remove this. Let me also, even though we just sort of like went through this ourselves, let me also add this to our test cases. Right, and over here, as they're going through these, anytime we subtract 1 from the target frequency, it'll always equal 0. It'll never go below 1. This one, this will be 0, this will be 0, but then we get to 11, it's undefined instead of target, so we return false for this one. So let's submit this one again, and let's see what we get. Okay, 73.45. So yeah, pretty happy with this. I do realize that we can say here, so we can probably sort of condense this, although, see here we can't just say if not target frequency value, right? Because then that would mean it's 0. So it does actually exist. So here we could just say if target frequency value undefined. I mean, if you want to sort of make this a little bit easier to read, you could put this on 2 lines like this. You can decide, you know, what you think is nicer, and I guess you don't even really need this piece here. I don't think this is too nice though, but let's just submit that. There you go. So again, think about time complexity. We're going through every value of target, and we're also going through every value of array. Now, something that I just realized, does it make sense if the array sizes are not equal? Could we do that? Like, do we necessarily have to use every single letter once? No, I think that's fine because, target and array. You can follow the next steps to convert array to target. That could be something that maybe we can plan for in the beginning. I mean, I kind of want to, if target dot length is not equal to array dot length, return false, right? Because if this is a 7 and this is like 1, 2, 3, 4, it doesn't matter how many times you reverse either one of them, you're never going to get the other one. So if target.length is not equal to array.length, we return false. Let's submit this. Okay, so just based on at least the first one that we submitted, it looks like we got slightly better time complexity here. But now let's go through a more sort of like a big O of n analysis here. So we go through target and we go through array, which we know have to be the same size. If they were able to be different sizes, then we might be able to say it's O of m plus n. But in this case, they're both the same size, so it's really O of n, right? We're going to do an O of n operation here and O of n operation here. All these other expressions here are just constant. So it's O of n for time complexity. And then for the target frequency, you know, we are keeping a map of n values, which is target. So it's also going to be O of n. So similar to the algorithm that we did prior to this one, we have a linear time complexity algorithm and a linear space complexity algorithm. So making really good progress today. Really, really happy about this. So let's get to the next one. So minimum subsequence in non-increasing order. This is a hit or miss because the like to dislike ratio is very close. The only thing I'm not in love with is this wall of text. But what I will do, let me actually, because reversing subarrays, I liked this question. Even though, I did like it. I'm going to add it to the list. I think it's good to be aware of that one. Okay. Yeah, I think we're in this one. So given the array nums, obtain a subsequence of the array whose sum of elements is strictly greater than the sum of the non-included elements in such a subsequence. Wow, that's a weird description. If there are multiple solutions, return the subsequence with minimum size. Okay, let me see what this says. I feel like an example is the only thing that can help me here. So we have 4, 3, 10, 9, 8, 10, and 9. The subsequence 10 and 9 and 10 and 8 are minimal such that the sum of their elements is strictly greater than the sum of elements not included. However, the subsequence 10 and 9 has the maximum total sum of its elements. Minimum subsequence in non-increasing order. Given the array nums, obtain a subsequence of the array whose sum of elements is strictly greater than the sum of the non-included elements in such a subsequence. If there are multiple solutions, return the subsequence with minimum size, and there still exist multiple solutions, return the subsequence with the maximum total sum of all its elements. Okay. Non-increasing order. 7, 7, 6. The subsequence 7, 7 has the sum of its elements equal to 14, which is not strictly greater than the sum of elements not included, which would be 4, 4, 6. Okay. Therefore, the subsequence 7, 6, 7 is the... Oh, okay. I think I know what we can do. It's a sort of a weird question, but I think this is almost a mix of like sorting and possibly a prefix sum. Let's see about doing this. So what I'm thinking of doing is, what if I, by default, sort this in decreasing order, right? Like 10, 9, 8, 4, 3. And what if we start, like, we want the minimum, right? But if I know, okay, I think I have an idea here. Like, the sum of this will be, like, this will be 1. Here, right? Is it, when you do a prefix sum, is the first one, it's just the sum of all numbers up to and including this position? I think, let me go with that. So this will be 3, this will be 7, this will be 15, this will be 24, and this will be 34. Let me line these up. 24, 7, and 3. I know it's not. Just imagine that each one of these corresponds. So like here, this is 24. So if I only choose 34, will it be greater than, let me see, subsequence 10 and 9 are minimal such that the sum of their elements is strictly greater than the sum of elements not included. So if I do 10 and 9, that's 19, and 8 plus 4 plus 3 is 15. So maybe actually, to make it easier, let's have a 0 here. Let's have a 0. This is 3. But now how do we plus the previous one? 8. Well, that wouldn't make sense, right? So what would this be? 7? And then this would be, yeah, that's strange. I don't know if that would be 16. Like, could we use this somehow? 10, 16 is bigger, so we need another one. That's 10 and 9. That's greater than 8 plus 4 plus 3. So at here, we should have 15. I can't pick 10 because everything else. Okay, no, I think that's fine. I think it's gonna be that. So yeah, it would be a 3 here, a 4 here. 7 plus 8 is 15. This would be a 24, and this would be a 34. So if I pick just the 10, is 10 greater than the sum of all the elements to the right of it? No. So let me include 9. Is 19 greater than the sum of all the elements? 15, 4, 3. It's 15. Yes. It is. So let's do now this next one. We'll sort it in decreasing order. We can do 7, 7, 6, 4, 4. Now we have our prefix sum. So here we have 4, here we have 8, here we have 14, then we have 21, and then we have 28. So I say, is 7 greater than 21? No, it's not. Is 14 greater than 14? No, it's not. But the next one is strictly greater. So I think this is what we need to do, right? So what's an easy way to calculate the prefix sum here? I mean, is that like a separate step I have to do, or can I sort of do it as I'm going along? I think it's going to be a multi-step process here. So let's do sorted nums. We'll get a copy of nums and we'll call our sort method. And we'll do b minus a. That way it's sorted in decreasing order. Now what I want to do, let me see, how do I want to do this? I mean, I suppose we can create const prefix sum. We're going to make this a new array equal to nums.length, and we'll fill it up with 0. What I can do here is I can say for let I equals to prefix sum dot length minus 1, I greater than or equal to 0, I minus minus. So we'll just start off, right? We're just always going to add the next one. So could we just do if, here we can say if I is equal to prefix sum dot length minus 1, and we'll just say prefix sum of I is equal to sorted nums of I, else prefix sum of I equals, and this should actually be just this, or plus or equals prefix sum of I plus 1. Let's do a console log of prefix sum. Just want to make sure we're getting the right thing here, and I actually want to use it for all my different test cases. 3, 3, 3, 3. Okay, that should be the lowest one, and then 4. Okay, and then 6. That's fine, but that shouldn't be it, right? If I equals prefix sum dot length minus 1, else prefix sum. Oh wait, prefix sum needs to equal sorted nums. Yeah, this should be equals sorted nums of I plus prefix sum at I plus 1. Right. Yes, exactly. Cool. So now as we're building this up, we can say const min is equal to some array, and now we can start counting from the beginning of sorted nums, right? So we can say for let I equals 0, I less than sorted nums dot length, I plus plus. What is it that we want to, maybe this should be I minus 1, because I'm always going to want to get the next thing, and the next thing, like I can't, if I'm at the end of this, I don't want to go out of bounds, right? So we're going to return min here. And now I ask myself, if the current has to be strictly greater, right? If it's less than or equal to, then we push it. So I think I could say if sorted nums of I, let's think about this prefix sum again. Let's get that first one. That's going to help me a lot here. 34, 25, right? This is 410. So I can say if I include the 10, that'll give me 34. So is 34 greater than, no, it needs to be 10 plus 9. 10 plus 9 is 19, which is greater than the next one, 15. 10 plus 9, I should always have the current sum too, right? So I do have to be, yeah, let's say const min, and let's say let sum equals 0. I can say sum plus or equals sorted nums of I. That will give me 10. Now I can say is 10 greater than or equal to, no, if 10 is greater than the next one, then we can break. Sum plus or equals sorted num. We should probably also add it at this moment, so we can do min.push sorted nums of I. And then if sorted nums of I is greater than prefix sum at I plus 1, then we break. So let's go over this. This one's a little bit, could be a little bit tricky, but let me sort this one out. All right, we're gonna have a 10. We're going to have a 9, and then an 8, and then a 4 and a 3. Let's think about where we are here. We're using sorted nums here as our I. So sum plus or equals sorted nums I, so that equals 10 to start. We also push 10 into our array, and we say if sorted nums of I is greater than prefix sum of I plus 1, 24, then we break, but it's not. Now we include the next sum. Sum plus or equals sorted nums of I. So this will now be 9, right? Because that's the next one. Min dot push 9. And now we say if, so it shouldn't be if sorted nums of I. It should be if the current sum, if the sum is greater than prefix sum at I plus 1, then we can break. And we'll just be left with 10 and 9. So now let's do it for this one, since I think this one's more interesting. Right? We're gonna have, can we get the yeah, here we go. This is gonna be the prefix sum for that next one. Let's also write this one out. We're gonna have a 77644, 77644. Let's do this one again. Sum is 0, min is an empty array. So we start at I right here. We add 7 to sum. We push 7 and we say, is 7 greater than sum of I plus 1, which is 21? No, it's not. Now we go to the next thing. We add another 7. So sum becomes 14 now. Now we add 7 to min. Now we say, is 14 greater than I plus 1? No, it's 14. So now we go to the next one. We add 6. We add 20. 20 is greater than 8, so we break and we return min. Now this one, let's make sure we're also, because this is like an edge case, right? This is a little bit of an edge case here. We have 6, and then we just have a prefix sum of also 6. So what happens here? I less than sorted nums dot length minus 1, and then we just return min, which so far we haven't put anything in there. So should we go to I minus 1 or sorted nums dot length minus 1? If I don't do that, how will I ever know? So maybe I can just go through sorted names, sorted dot nums dot length minus 1. Maybe we can go through all of them. That way we add 6 and we add 6 here. But I can say that if we're at the end, right? If I is equal to sorted nums dot length minus 1, or sum is greater than prefix sum, we can break for either of these cases, and then we can just return min, because at least in this case, we'll get our min of 6. That's what I'm thinking. Let's try this out. So 10, 9, 7, 7, 6, and 6. Let's run this. Okay, 60.67. So this is cool because I'm like, I noticed that I feel like I'm getting better at this just because I'm talking out loud. Hopefully for the people that are watching, they also feel the same way. I really hope you all do. I hope, Rashawn, you're still watching and you're gaining some value from this, because things like this, like when I see a question like this, we see the like to dislike ratio. It's like borderline, right? And I could almost see how it could be that, because this edge case, while it's something that you should know how to do, it could be a little bit tricky to get. But let's think about the time complexity here. I want to run this again and see what we get. 79.78. It's a couple of things we did here, right? The first thing we do, like this sorting algorithm, I think for each one of these we'll do T and S. T, this is going to be n log n, right? Because this is using quicksort. Best case scenario, or I believe in worst case scenario, we know that quicksort will use log n of internal space. Then here for our prefix sum, to be able to create a new array, it's going to be a linear time operation, and we'll also have a linear space complexity. For I equals prefix sum, this is also going to be a linear time complexity. This will just be constant space. We're not really like, we've already allocated the space for the array. We're just now putting variables in each of their indices. For this one, right, we're going through sorted nums.length. So that's O of n. And then for min, like at worst, we might need every single number in the array, or at least most of them. So this can also be like a linear time or linear space. So what's our bottleneck here? The biggest one, right? It's going to be bounded by n log n, and the space will be n. So an n log n time complexity with an log n space complexity. The percentages I'm getting here, I do like. Let's see what discussions have to say. Java priority queue. Let me see the solution with sort. So nums.sort, while sum of res is less than sum of nums, we can res.append without summing every iteration. Is this doing, what is this doing here? Oh, it just takes the sum. Okay, the sum of the res is less than the sum of nums, then append nums.pop. Average is about popping elements, but returning a slice. Right sum minus equal to num, left sum plus or equals to num. Yeah, this is very elegant here. So he sorted it. He creates the res like we did. And now, so that will be 0 less than or equal to the sum of the total. We can append the greatest one. Oh, I guess we can keep, yeah, that makes sense, right? We can keep popping the greatest one while the sum is less than or equal to. Only when it becomes bigger do we want to break. So maybe we don't even need to, let me do this, right? I kind of want to explore that solution a little bit here. I do like that one. Now we don't have, we can do sorted. We don't need prefix sum, so I'm just going to comment all this out. I'm going to make this let. And now I'm going to create my own. I don't think there's a sum function as far as I know. I'm going to create this r, and this will just return r.reduce acval act plus val 0. This is just to sum the numbers if you pass in an array. This is just using JavaScript reduce. So now we can say let min equals this, and we can say while the sum of min is less than or equal to the sum of nums, we can do min.push. Let's see, we want to get nums.pop, right? Or it's not here, it's actually not going to be nums.pop. No, yeah, we don't even need to decrease it. Yeah, we don't even need to have it in decreasing order. We can actually have this as a minus b. And then we can say nums.pop. So while sum of min is less than or equal to sum of nums, min.push nums.pop, return min. I suspect this might sort of go into infinite loop territory. Let's see. Const min. Oh, all this stuff down here. Eight, 9, 10, 7, 6, 7, and 6. While sum of min is less than or equal to sum of nums, min.push nums.pop. So we took the greater one off. Oh, this should be sorted nums. Sum.min is less than or equal to nums of sorted nums.pop. 10, 9, 7, 7, 6, and 6. If we run this, 67.42. So it seems like it's about the same. yeah, I'm not. I mean, it's a cool solution. I'm also happy with the original one I came up with, only because I feel like I was able to I guess train more stuff. Does that make sense? Let me see. Okay, so let's get out of this. Let's submit this one. This should be the winning one here. 73. Yeah, so I like this one more because I just feel like I was able to train in more areas, like with prefix sums and sorting, sort of going through this motion right here. So I do enjoy this one a lot. Maybe it's not as clean, but I'm happy with it. So let's move on to the next one. So check if all A's appear before all B's. So we have, given a string S consisting of only the characters A and B, return true if every A appears before every B in the string. Otherwise, return false. So I mean, once I see B, I can't see any more A's. That's essentially what it is. Right? Because here I got to a B and then I saw the A. Now I can also just start from the back. If I start from the back, what is that gonna do for me there? Can I use 2 pointers to do this? I should be able to make it all the way through. Is this always gonna be? No, it can be A, B, B, B. If I see a B, I just never get to any of the A's. See a B, never get to any of the A's. What if I just say, so what's the, let me see. We can have a string that has all B's, right? So if I don't find a B, then we can return true. Find B index. If find A, return false, else return true. So I think there's one called I know there's index of, and maybe that's what we can use. I think index of will give us -1, right, if it's not present. So let's say, right, like we can say const b index equals s dot, and I think index of is also in strings as well. Yeah, index of, it's part of the prototype. So s dot index of, and does this just take the substring? Okay, index of b. If b index is equal to -1, then we just return true, right? There's no b's, there's only a's. Else we can say for, and let's make this let b index, for b index less than s dot length b index plus plus. If s of b index is equal to a, we can return false. Else here we can return true. So let's go over like what I did here. Let's run this code first. True and true. So spoiled by that premium. True, false, true, false, true, true, false, true. Let's run this. 21.98. Let's see. 93.5. So I'm pretty happy with that. So what do we do here, right? There's like a couple different edge cases I thought of to myself. Like first of all, there's a case where we can have all A's inside of our string. Right? And you might be thinking like, oh, what if I just check the end of the string and maybe if that's an A, that's fine, but there could be like a B in the middle, so then that wouldn't work. So I just check to see, is there a B in here at all? If I get -1, there's no B's, so I know it has just all A's, and I can immediately return true. Else, we can just start from B index, go the rest of the way. If I ever find an A afterwards, I return false. I just return true at the end. What I did here is normally a for loop has that first part of it that sets up the variable, and then you have your condition and then your incrementer. But you can actually bypass that and just introduce a semicolon here, because I already have my index that I want to start off with B index. So that's sort of what I'm doing here. So I feel pretty good about that. I mean, yeah, I think this is pretty good. Time complexity here is like index of is most likely going to be linear. It has to scan the entirety of the array to be able to get it. So it's linear plus another linear here. That's O of n. And our space complexity seems to be constant here. So yeah, I'm very happy with this. Python one-liner, find BA, check if sorted. Oh, I guess return BA not in S. Yeah, I mean that is one way to do it. I wouldn't like, I mean that's a way of doing it. I wouldn't worry about this too much. If you feel like, oh, I didn't get this, I should be able to get this. Yeah, it's definitely, it works, but I also think this is just as valid. I wouldn't be too concerned. Okay, cool. Smallest index with equal value. Doing really good today. I'm very happy with our progress today. Given a zero index integer array nums, return the smallest index I of nums such that I mod 10 equals nums of I, or -1. So x mod y denotes the remainder. So 0, 1, 2, 0 mod 10 is 0 equals nums 0. So we return the smallest index 0. I mean, can we just traverse? 2 is the only index which has mod, and that's the smallest index. No index satisfies. So I think we can do find index of the first element or no elements. Yeah, I think we can just do this. Now this find index, what does find index takes? Element, index, and array. I think what we can do, we can say nums.find index. Here we have an element, an index, and an array. We can say value or index. We want to find the index of such that I mod 10 equals to nums of I. Here we'll also get the original array. Here we can return index mod 10 is equal to R at index. Right? And this will just return -1 if it doesn't exist. I think this will work. 0 and 0. Too fast here. Let's try again. Zero to -1, 0 to -1. Yeah, I mean this is a really nice question for find index. This is like the point of find index. I think this one's okay. I like this one. I don't think it's terrible. And we're not even using value here, so we can make this a little bit more condensed by just saying we're not going to use it. But we do need the index, right? Because that will be the I value, and then we also want the reference to the original array. We get that through R. We can also, since we're just using this here, we could condense this and just leave it like that. I think we can even get, no, we can't. It would be nice if, yeah, because we also need that. We need find index, so we could leave it like this. R of index, it doesn't like this piece here. I mean, if I really squeeze this inside, make it a one-liner. That's the nice thing, right? Like find index returns -1, so it just gives us the answer. 30.43. Let's run it a couple more times. 33.82. Okay, so there's definitely a much faster way to do this. Maybe we don't need to check every single index. What's the math behind this? Because sometimes you got to think like something that almost feels this easy. Remainder, the smallest index. I mod 10. Let's see what discussions have to say. Not sure what is the point. something we can learn from this question too. Since modulo operators are very heavy operators, so instead of doing modulo every time, we can just skip the elements who are greater than 9, and the code's execution time comes down from 60 milliseconds to 8 milliseconds. This kind of stuff usually comes handy in interviews. Maybe to make people feel better about their coding skills. That's rough. But you know what? Even if that's the case, there used to be this thing on Reddit that was like, man, I'm gonna take a minute to look for this. I don't want to spend too much time. It was something about Dark Souls, like Reddit Dark Souls meme respite or something. The whip, a brief was it this? I just remember there was like, sometimes like people would have these posts here, this like moment of respite, and as you'd be scrolling through Reddit, it would just tell you, it would just show you this and be like, oh hey, just relax for a second as you're doing, you know, mindless scrolling. But I almost feel like that's maybe the point of this question here. You know, we're doing all these questions left and right. We get to this one, you know, it's an easy question. We feel good about ourselves and we say, hey man, we're really learning. I feel really good about this. So let's consider this our moment of respite, a brief respite. I like it. All right, let's see how many more we can do here. Got about 9 minutes left. I do want to make a sort of a strict cutoff at an hour today because I want to go on my, I try to do like a walk every day, and I haven't gone today, so I want to do that after this before it gets dark. So smallest index with equal value, squares of a sorted array. This question is phenomenal, and I'm super happy that we were able to stumble upon it, and it could very well be the last question we do. So yeah, this is very good. Very good question. We're going to solve this in two different ways, because if you look at the follow-up here, it says we can just square each element and sort the new array, right? Squares of a sorted array, and you just want to return it in increasing order. So one very easy way of doing this is saying return nums, then we do a map where we take each value, and we do math.pow of value to the power of 2, and then we just sort that in increasing order, right? That is one thing that you can do, right? And literally just gives you the answer. Now, when I'm talking about this here, I don't want to make it seem that, you know, it should be obvious that you can do that. Perhaps this easy way, maybe, because it's literally, it's sort of in the name, right? You might think, okay, it's obvious that maybe I can just square everything and then sort it. And the worst thing, maybe not the worst thing, but it's sort of misleading that you get 85%. Like that's actually, you know, it makes you feel like, oh, that's really good. And also, Rashawn, yeah, walking is by far like that's my brief respite for the day. It's like my favorite part of the day. It's very calming just to be able to walk, listen to like a good podcast, and it's fun. Okay, 16.66. So let's think about another way of doing this. This is like, it's big brain time over here, all right? We're going to figure this out. We have, is this squares of a sorted array? So the array is already in increasing order. We just want to get the squares of each number and put them in their right place. But as you've probably noticed, you may have thought in your head of an example of like 1, 2, 3, 4, 5. Okay, I can just do this thing where I sort, or I can just square each number and sort it. Now, you may have noticed that some of these are negative, but negatives, when you sort them, might be greater. Like, right, this becomes 49, and this becomes like 121. This becomes 9, right? Like, there could be a case where, like here, like 16 is greater than 9, right? So we have to sort of like take account of that. And there's one very good way of doing this, and it's the classic two-pointer technique. Let's get our different spots here and start thinking about how we might be able to do this. Imagine we have 2 pointers, right? We have start and we have end. We can take the results of each one of these. Like start is 16 and end is 100. That's the square. So which one of these is bigger, 100 or 16? Well, 100 is bigger, so we should put 100 at the end. And now we decrease end by 1 since we picked the largest one. Now we do the same calculation again. We say 16 or 9. Which one's bigger? 16 is bigger. Now we pick 16. We go up for start. Now we say, is 1 bigger or is 9 bigger? 9 is bigger, so we pick 9. We go down for end. Is 1 bigger or is 0 bigger? 1 is bigger. Now we sort of have, we'll have our S and our E in the same spot. 0 or 0 bigger, it's just 0. And I guess we don't even need to do the calculation. Once they're the same, right? Once they're equal, we can just set the final index. So what is it that we just did? We created two, right? We have, let's first say const sorted array. This will be equal to a new array that's the size of nums.length. Now we can create our start and end pointers. Start is 0, let end equal to sorted array dot length minus 1, right? Now while the start is less than or equal to end, all right, and actually we can just do start is less than end. Once they're equal, we'll just set the last number to be whatever it was inside of this sorted array that we have here. So now we have nums in here. So let's think about this, right? Let's get the result of the left. So we say const start, let's see, start squared is equal to math.pow of nums at start, power of 2. We can do the same thing here. We'll say const end squared. Let me just like expand this. Let's get some room. N squared is math.pow of nums at end squared. Right? We can say if start squared is greater than n squared. We also need like an index, right? So we need to say like let insert index equal the same thing. We can just set that equal to end. Now we'll say sorted array at insert index is equal to start squared. Then we say start plus plus, since we picked the start, right? And at the end, or not at the end, else, if the end is greater, then we choose the end one, and we say end minus minus, and we always decrease insert index, right? Insert index minus minus. That's always going to be what we put in the next spot. And then at the end, once they're equal to each other, we'll break out of this, and we can just say sorted array at insert index is equal to nums at start, for example, return sorted array. So let us now remove all this stuff. Let's run the code here. 019, 16100. Okay, now we're getting 299. I don't know where we got the 2 from. I think maybe I'm getting the 2 because I'm not actually, yeah, I need to actually math.pow of nums.start at 2. Okay, so I almost thought I would be able to like get away with doing this, but you know what? Let's just make this less than or equal to so we don't have to do this thing at the end. And now we should just be able to return our sorted array. 499, 49121. Let's submit this. Let's expand this. 82.43. So exactly a 2-pointer approach. This is a classic. I mean, this question is so good. I suspect that when we start getting into like mediums and harder easies, we'll be seeing a pattern like this very often. So we create a sorted array. This is just going to hold our result, right? We have a start and an end pointer that's going to be used to traverse our input nums array. And then we have an insert index that we'll use to actually insert items starting from the end of the result, sort of going down towards 0. Again, the same thing. We compare the result of squaring the first thing at start to end. Whichever one's bigger is the thing that we put at insert index. If we picked start, then we increment start. So the next time we look at the next, the next one in the sequence. If we do end, then we decrease end. So the next time we look at the next one in the sequence. Keep doing that until this condition is false, and then we just return the sorted array. So remember, last time we were sorting and squaring, that was an n log n operation, but now we're using this two-pointer approach and just pretty much going through we're not even really going through well, I guess we still have to visit every element once. So it's still O of n, linear time, and also the space complexity is n as well, because we're at the end creating a sorted array anyway. So I'm really happy that we ended off like this. This is a very, very good question to end with. Let's see. We started today at 116. I know we're going to be over 120. Maybe 122? 122. Awesome. So yeah, we did 6 questions. So averaging about 6 questions a day, maybe. Well, today we did 6 questions. I think yesterday we did like 3 or 4. So we're at least doing like 30 questions a week. So we can do like 120 a month. You know, we're already, I think, faster. Like, we haven't even been doing this for a month and we're already at 122. So I would say that's like phenomenal progress. By the way, there's only been one time since I've started LeetCode in this 3-year journey of mine that I've ever been above 122. And I know it's all easies, but it's still a lot of progress. So if you've kept up with me, like, definitely give yourself a pat on the back. And, you know, understand that you're doing the thing. We're learning a lot. This will carry forward with a lot of other software engineering that you do in general. So with that being said, I am going to cut off the stream at this time now. I think last night went to like an hour and 40 minutes. So thank you all so much for joining. Thank you so much for watching. Be sure to hit that subscribe button if this is your first time watching. That way you'll be notified of all the different live streams that I end up doing. And also hit that notification bell so you'll know exactly when I have my live streams coming up, and you'll be able to get that notification so we can just keep the grind going and, you know, let's fulfill all of the goals that we want to hit. Thanks again, everyone, for checking in. Have a great rest of your Tuesday, and happy coding.